Today we're talking about how to simplify radical expressions and solve by square roots. Okay, so square root, square means what? 2. You guys are smart. Okay, so when you, and you should know this from Algebra 1, but we're going to break this down to figure out if we can find 2 of any of the same numbers. So, what 2 numbers multiply to be 75?
3 and 5.
Good. And then 25 is 5 and 5. So this is like your factor tree. Does that sound familiar?
Yeah.
Okay, so there is a group of 5s and there is a 3 left over. I normally will like circle my groups and then box anything that doesn't have a pair to remind me that it needs to go back into my root box. Okay? And so when you have a pair, that ends up just becoming a single 5. So my answer for this is 5 root 3 because the 3 is still in the root and the 5 got to be brought out. Questions on example 1. Okay, example 2. So you always just kind of break it down what makes the most sense to you. So when I see 450, I think 45 times 10. If you see it a different way, you can do whatever you want. But I'm going to write down 45 times 10 because that's easy for me. And then I know that 45 is what?
5.
Good. 9 times 5. And then I know that 9 is 3 and 3. So right now I know I have a group of 3s. And then 10 breaks down to 5 and 2. So I have a group of 5s. And then I have a 2 left over. So when I bring my group of 3s and my group of 5s out, what do you do with them? So what will my answer be?
2.
Perfect. Okay. Example 3. 24 breaks down to what 2 numbers?
6 and 4.
Okay, either way. So I'm going to write 6 and 4. I know that 4 breaks down to 2 and 2, so that's a group. Now, 6. I'm going to get a 3 and a 2, which I know is not going to give me a group. If you know you're not going to get a group from something and you don't want to break it all the way down, and you just want to box it because you know that it's not going to make anything, then do that. If you want to break it down and box both those numbers, you can. So when I bring the 2 out, there's already a 7 there. So what do I do? Good, you multiply them together, so we get 14 root 6 is correct. Okay, now when you have 2 of them multiplying together, outside of roots multiply together, inside of roots multiply together. Okay, I would go ahead and put this all together. So how I'm going to write this, I'm going to go 8 times 2, which is, but inside the root, since I'm going to already go ahead and break things down, I'm just going to write this as 21 times 35 instead of multiplying them together. And then I'm going to break those down. So 21 breaks down to what? Good. And then 35 breaks down to? So I have a group of 7s, and then I have a 3 left over and a 5 left over. So when we bring the 7s out, we're going to go 16 times 7, which is? Very good. 112. And then what's left over inside? 15. And that's my answer. Okay. So, questions so far? All right, moving on to example 6. Has anyone ever heard of rationalizing the denominator before? Sounds a little familiar. Basically, you cannot have any radicals, roots in the denominator. Okay? So I'm going to write that here. This is what it's talking about. So when you're rationalizing the denominator, you're basically getting rid of the root that's in the denominator. There's just a couple things with roots. Do you notice how 9 and 7 are both under roots? Yes, this is under a root, this is under a root. Yeah, we're good with that. Anytime both the numbers are under the roots, if you could reduce like 9 and 7, you can reduce them, okay? Numbers outside of roots, you can reduce. But you can't reduce a number that's under a root and one that's not in a root, okay? They have to both be under or both be outside, okay? It's up to you here, but I usually try to like simplify the roots first, and then if I have to rationalize the denominator, then I do. So I can't simplify 7, but could I simplify 9?
Yes.
Yeah, because 9 breaks down to what? 3 and 3. So now I really have 3 over root 7. Do you guys agree with that? Okay.
Multiply by root 7.
You're going to what?
Multiply by root 7.
Very good. So in order to rationalize the denominator, you need another root 7, right? Because when you're multiplying roots, remember how back here on this example up here, how when you're multiplying roots, both of them end up being under the same root? So if I multiply root 7 and root 7, I end up with 2 7s under a root. But whatever you do to the bottom, you also have to do to the top. So we also have to multiply the top by root 7. So the bottom, the whole purpose was to get rid of our root, which we do because now we have a pair of 7s. So we have a 7 in the denominator. And then on the top, I have a number not in a root and a number that's in a root. So that just becomes 3 root 7. And that is your answer because we can't reduce any further. Are there questions on that? No? Okay. So moving on to example 7. Do you notice anything? Can I reduce this at all first? Is there any number that can go into both 9 and 20? No. Okay, so I'm not going to reduce it, but this is the same thing as having root 20 over root 9. Now, can I simplify these at all right now? Yes. So 9 we know breaks down to what? So we have a pair of 3s, so my denominator here is 3. And then can 20 break down?
Yes.
To what?
Radical 5.
Good. So I have 4 and 5, and 4 is 2 and 2, so we have a pair of 2s and a 5 left over, and that makes 2 root 5. And then you check, can I reduce anything there? No. So that's my answer. Example 8. Can 3 and 50 reduce? No. So again, we can rewrite this as root 3 over root 50. And then now we check if we can simplify these separately. So can 50 break down?
Yes.
To what?
5.
Okay, I'm going to write it as 5 and 10. And then we have 5 and 2. So I have a pair of 5s and a 2 left over. So that is 5 root 2. And then on the top we have root 3. Is this answer okay? No, because we can't have a... Good. And the only way to get rid of it is we call it what? Good. And that's called doing what? Rationalizing the denominator. So we're multiplying by root 2 to both the top and the bottom. That makes a pair of 2s, and I already have a 5, so what happens? Okay, and we end up getting 10. And then on the top, can I break either of those down? No, so what I end up with? Can I reduce those? Why not? Good. Very good. They either have to both be under a radical or both be on the outside. So that is my answer. Okay. So this next part, we need to rationalize the denominator by using the conjugate. The conjugate of a plus root b is a minus root b. Now, if you guys think about this, remember, like this is basically kind of like difference of squares. And when you multiply them together, you get rid of kind of that middle term. Do you guys understand what I'm saying by that? For instance, let me show you in case you're saying you understand, but you really don't. If I multiply x minus 2 and x plus 2 together, and let's say you did your little box here, you have x and negative 2, x and positive 2, we get x squared, negative 2x, positive 2x, and a negative 4. These x's end up canceling out, okay? If you have a root and you end up multiplying it by the same root, it gets rid of the root, right? So the conjugate is basically just the opposite middle sign, okay? Because if I were to just multiply on the bottom by root 5 to try to get rid of the root 5, you'd end up with 3 root 5 plus 5. So you'd still have a root, right? So whenever there's adding or subtracting in the denominator, you have to multiply by the conjugate in order to rationalize the denominator. And so what would the conjugate be on this one? Right, 3 minus root 5 is correct. And whatever you do to the bottom, you also have to do to the top. So if you look at step 1 of the instructions, it says multiply the numerator and denominator by the conjugate of the denominator. So that's what I'm doing. Now, let's go ahead and multiply this out to see what happens by using our box method. So I'm going to make my box, and we have 3 and a positive root 5 and 3 and a negative root 5. So when we multiply here, 3 times 3 is 9. 3 times root 5 is 3 root 5. 3 times negative root 5 is negative 3 root 5. And negative root 5 times a root 5 will give us what?
0.
Negative 5. Okay, so let's just look at this to the side. Root 5 and root 5, if you're multiplying those together, that makes a pair, right? So it's just going to make a 5, but it's going to be negative 5 because a positive times a negative is a negative. Do we agree with this? Okay, so what happens to those terms? They cancel out. 3 root 5 and negative 3 root 5, those cancel. So now in my denominator, all I have is 9 minus 5, which is 4. Then on the top, we're going to have to distribute. 7 times 3 is 21. And 7 times negative root 5 is?
7 minus 5.
Good, negative 7 root 5. Okay, now in order to reduce something like this, you'd have to be able, this number would have to be able to reduce into both of these. Or you could separate it into 2 fractions and reduce that way. But 4 can't reduce into either 21 or 7, right? Okay, so that's my answer. Now, I'm curious if looking at this here, do you see a shortcut that you could possibly use instead of making your box? So, right, it's just like here. It's your front 2 terms multiplied together, which would make x squared, and your back 2 terms multiplied together, which makes a negative 4, right? So it's the same thing here. Your front 2 multiplied together, which would make a 9, and your back 2 would multiply together would make a negative 5. But could you always use the box and make sure you do it correct? Yes. Okay. Questions? No? All right, moving on. Do you guys want to try number 10 on your own? Okay, it looks like most of you got it. I'm going to go ahead and start going through. The correct answer, if you want to check really quick, is 9 root 3 plus root 6 over 79. Okay, so what is the conjugate? What am I going to multiply by? Good. And whatever we do to the bottom, we also do to the top. Okay. Now, if you're going to do the shortcut, you need to make sure you do it correctly. If you aren't doing it correctly, then I would say make your box and multiply it out. But you're multiplying the front two numbers together, 9 times 9, which is 81. And then negative root 2 and positive root 2 makes a negative 2. And 81 minus 2 is 79. Then you're distributing. Root 3 times 9. If there's no number in front of the root, there's really a 1. So you're multiplying 9 times 1, which is 9, and then you have the root 3. Because you can only do whole numbers with whole numbers, radicals, roots with those, okay? And then here we take this and multiply it here, and see now we have 2 roots, and root 3 times root 2 is root 6. And there's a plus sign there, so we put a plus in between. And there is nothing that I can reduce, and that is my answer. Okay, questions? All right, next we're gonna talk about solving quadratic equations by using square roots. Last unit, we set everything equal to 0. You can do that as well this unit, but I feel like this way is a little bit easier. So I'm gonna write out the steps. They're not in your notes, so if you maybe wanna write these. Step 1, you want to get the square by itself. Step 2 is to take the square root of both sides. And step 3 is that anytime you take the square root of both sides, the answer is plus or minus, meaning you get 2 answers, okay? Bless you. Okay, so what I mean by this, on example 11 here, the square is by itself. Agreed? So in order to find out what the answer is for just x, we take the square root of both sides, the square root of x squared, because x squared is really x times x, right? So we have a pair of x's, so the square root of x squared is x, and we know that 49 breaks down to 7 and 7, so my answer is 7, but it's going to be plus or minus 7. If you think about this, if you plugged in 7 here, 7 squared gives you 49. If you plugged in negative 7, negative 7 squared is also positive 49. If we went back and did this the way we did it last unit, and I subtracted 49 to both sides and got x minus 49 equals 0, we factor, we get x minus 7, x plus 7, we set those equal to 0, and we get x equals 7 and negative 7. Do you guys agree? So it's the same way, but I feel like this is a lot less work. What do you guys think? Yeah, so that's what we're doing. Does that make sense why there is 2 answers? So whenever you take the square root of both sides, you will have 2 answers, plus or minus. Okay? All right, so example 12. What are we going to do? Very good. Take the root of both sides. So the square root of w squared is what? W equals, and we need to break 84 down. What 2 numbers could we break this down to start with? Okay, and for me, I'm like, in my head, I'm like, I have no idea what numbers multiply to be 84, but I do know I can divide it by 2, and so I would put 42 and 2. But whatever you want to do, you can. And then 42, I know, is 6 and 7, right? And then 6, I know, is 3 and 2. So I have a pair of 2's, I have a 7 left over, and I have a 3 left over. So when I write that, it's going to be what? Good. 2 radical 21, and it's plus or minus. Exactly. And that's your answer. Are we okay? All right. So going back to our first step, we need to get the... Good. Get your square by itself. So on 13, the square is not by itself. What am I going to do in order to get the square by itself? Very good. Subtract 8 is correct. Or you could have got rid of your fractions. That would also work. So we have t squared over 20 equals, and 15 minus 8 is 7. Now how do I get rid of the 20 in the denominator? We're going to multiply both sides by 20. So that cancels those out, and we get t squared equals 140. So now that the square is by itself, what do I do? Exactly. We take the square root of both sides. So the square root of t squared is t, and then 140 we need to break down. So what numbers break down for 140? Okay, I'm going to choose 14 and 10. You guys can choose whatever you want. And then 14 breaks down to 7 and 2, and 10 breaks down to 2 and 5. Good. So we end up with a pair of 2's and a 7 and a 5 left over. And so that answer is going to be what? Perfect. Plus or minus 2 radical 35. Questions? We're all okay with all this? Okay, moving on to the next one. 14. Okay, now this one is slightly different, but is the square by itself?
No. Yes.
Yes, because if you look, there is nothing else with the square, right? It's just that the square this time is x minus 3. Okay, so what do we do once the square is by itself? What is our next step?
Square root of both sides.
Very good. Take the square root of both sides. So we end up with x minus 3 equals, and do we know what the square root of 25 is? 5, but we write it as plus or minus 5. Now, anytime you don't have x by itself, in this case x is not by itself, you're going to write 2 equations because we're always going to end up with 2 answers. Okay? So we have x minus 3 equals 5, and x minus 3 equals negative 5, and we're going to solve. So on both of them, I'm going to end up adding 3 to both sides, but on one I get x equals 8, and on the other one, when I add 3, I'm going to get x equals negative 2. So my answers are x equals 8 and negative 2. Does that make sense? Yeah? All right, so 15. Is the square by itself? No. So what are we going to do?
Oh, you have to subtract 8.
Add 18. Add 18 to both sides. Very good. Okay, so I have 7 parenthesis x plus 4 squared equals 28. Is the square by itself? No. No. What do we need to do? You guys are smart. Divide by 7 to both sides. We get x plus 4 squared equals 4. Is the square by itself now? Yes. So what do we do?
Take the square root of both sides.
Very good. We get x plus 4 equals what?
Plus or minus 4.
Nope.
2.
Plus or minus 2, because 4 is 2 times 2. And then now, what do I do?
You just make 2 equations.
2 equations. Very good. X plus 4 equals 2, and x plus 4 equals negative 2. And we solve. So one answer is x equals negative 2, and the other answer is x equals. So my answers are negative 2 and negative 6. Now 16 is slightly different because if you notice on all of the previous examples, we didn't have any roots in our answers, correct? This one, you're going to end up with a root. So first thing is the square by itself? Yes, so what am I going to do? Very good. So we end up with x minus 9 equals plus or minus, right? And 24, what does that break down to? Good. So we have 6 and 4, and then 4 is 2 and 2. So we have a pair of 2's with the 6 left over. So how will I write that? 2 root 6, right? Well, there's no point on writing these as two separate equations because you're not going to be able to simplify it to be a single answer. So on this one, all I'm going to do is just add 9 to both sides. Can I add 9 with the 2 root 6? No, because 9 would also have to be a root 6 in order for us to put it together. So when you write this answer, you always want to write the part without a root first. So I'd write that as 9 plus or minus root 6. Thank you. 2 root 6 is what I meant to say. Candies for some of you. Now, if you separated that as two equations and you wrote x minus 9 equals 2 root 6 and x minus 9 equals negative 2 root 6, and then you went over here and you added 9 to both sides, you would get x equals 9 plus 2 root 6. Here you would add 9 to both sides and you get x equals 9 minus 2 root 6. Oops. Are these the same answers? Yes. So they both have the 9s. This is a plus, plus and minus. We just wrote it as a single answer here. Okay? So if you want to separate it still, you can. But if you know that it's not going to end up being able to combine, you can leave it as the 9 plus or minus 2 root 6. Any questions?